to be possible. However, what the team at NASA discovered this time made them rethink all their decisions and plans regarding safety and how they understand the sun. This can be equivalent to millions of nuclear weapons exploding simultaneously. The sun is vital as it helps sustain life on Earth. Advanced instruments and satellites, including NASA's Solar Dynamics Observatory, allowed us to observe and measure this solar flare's magnitude. The intensity of the solar flare helps determine the activities taking place on the sun, making it easier to predict future patterns. Data recording on the sun has been carried out for decades, and it serves as a great reference point, helping predict weather patterns among other things. The imagery captured by the advanced instruments and satellites showcases the sun's surface erupting with a massive plume of plasma, also known as a coronal mass ejection, CME. This ejected plasma, traveling at speeds of millions of kilometers per hour, is a distinct yet interconnected phenomenon with solar flares. While the solar flare itself is generally harmless due to the Earth's protective atmosphere, the following coronal mass ejection can interact with our planet's magnetic field, triggering geomagnetic storms. These storms, in turn, can impact power grids, satellites, and radio communications. On the mentioned Thursday, about 17 hours after the flare, the coronal mass ejection reached Earth, inducing a potent geomagnetic storm that persisted for several hours. With gravity crushing things down, when things get close enough together, nuclear fusion happens. Despite its disruptive nature, the geomagnetic storm had a visually spectacular outcome. It gave rise to breathtaking auroras, or northern and southern lights, visible in various parts of the world, including uncommon locations like Hawaii and Cuba. Auroras result from charged particles from the coronal mass ejection colliding with Earth's upper atmosphere, creating vivid displays of colorful lights in the night sky. Numerous individuals captured and shared awe-inspiring photos and videos of these auroras on social media, marveling at the wonders of this natural phenomenon. Now you might be curious as to why this solar flare stands out as unusual and significant. There are several reasons for this distinction. Firstly, it ranks among the largest ever recorded solar flares and holds the record as the most substantial one within the current solar cycle, an 11-year cycle representing the sun's activity. Here's nature giving us an example of how these phenomena work, providing an opportunity to study and hone our physical theories or calculational tools. By looking, for example, at the effects that we see on Earth, the sun's activity undergoes fluctuations, transitioning from periods of low activity known as a solar minimum to high activity known as solar maximum. Solar maximum is characterized by increased sunspots, dark patches on the sun's surface indicating heightened magnetic activity. More sunspots typically correlate with a higher likelihood of solar flares and coronal mass ejections. However, the ongoing solar cycle that commenced in 2019 has been remarkably decreased, featuring minimal sunspots and flares. Some scientists even projected it to be the weakest cycle in the last 2 centuries, anticipating a lack of major solar flares until 2024. We were able to figure out that if we use carbon, we can trace the origins of the solar wind with higher accuracy, allowing us to determine where it is originating on the sun. When the solar maximum is expected to peak, therefore, the occurrence of this massive solar flare during a period of low solar activity was both surprising and unexpected. This solar flare made the scientific community question their understanding of the solar system and what other surprises the Earth is in for. Science is based on facts, and these facts help determine several things, including how various natural phenomena affect Earth's atmosphere. The sun is one of the few things in the solar system that scientists are proud to study and understand based on facts and evidence. The scientific community has made strange discoveries, all of which have aided in making life on Earth easier. He brought to us this idea of sonifying data, which is really quite innovative and maybe even transformative. Unfortunately, not all discoveries have been celebrated with champagne, as some of them call for a major re-examination of all facts on Earth. This specific solar flare challenges our current understanding of the sun and its behavior, leading to questions about the accuracy of our predictions and the adequacy of our preparations for future solar flares and coronal mass ejections. It emphasizes the need to re-evaluate and enhance our understanding to better anticipate and lessen the impact of such solar events. To make it clearer, the solar flares should not impact the Earth in a massive way. The specific nuclear action that powers the sun is fusion of hydrogen into helium. You take two hydrogen atoms, you ram them together, and what's left over is a helium atom. However, in cases like these ones, the flares can disrupt several things. Remember, the flare is a surge of energy that interacts with the Earth's atmosphere, creating a geomagnetic force that is seen as the northern and southern lights. In most cases, the flares are not harmful. However, the scientific community has taken pride in knowing that it can predict when the next flare will happen and detect it early enough. In this case, it wasn't expected to be such a huge solar flare, as the sun is in its minimum period. Such a surprising event makes scientists question their understanding of the sun. There are several worrying questions that threaten everything the world knows about the sun. If such a solar flare can happen so unpredictably, is Earth well equipped for a larger solar flare? Is what we know about the sun sufficient, or are we just learning the basics? Indeed, the solar flare on Thursday presented both risks and benefits. As reported by Earth.com, power grid fluctuations were likely affected, and spacecraft in low Earth orbit could have experienced irregularities and communication issues. The full extent of blackout impacts remains unclear. A phenomenon like this was periodically happening every roughly 27 days, which is exactly the rotational period of the sun. The Earth is one big communication dish, relying on satellites to get information about everything. If a solar flare interrupts the satellite's waves, communication becomes hindered, and there are serious chances of having some parts of the world cut off. Similarly, the world is so dependent on power that a little bit of fluctuation can affect continents, leading to serious hazards. Such things are what the scientific community has tried to avoid by studying the sun intently and recognizing the times when a solar flare is released, which is crucial. So when such a surprising flare is released, the team is worried that maybe they don't have the sun figured out just yet. This makes the team reconsider all their plans for protection. The Earth's atmosphere protects the surface, but what if the sun's activity is increasing? While it is interesting to document the largest solar flare yet, it is also worrying to think about the implications. On the positive side, solar flares have the ability to create spectacular auroras. It's actually hard to get two atoms to fuse. Two protons have the same charge, they're both positively charged and want to repel each other. These auroras not only offer a beautiful visual display but also provide valuable information about Earth's magnetic field and atmosphere. Studying auroras helps us understand how the magnetic field protects us from solar wind and coronal mass ejections, and how it changes over time and space. Such information makes it easier to study various phenomena and understand their implications on Earth and the effects they cast upon life. Additionally, it aids in researching the chemistry and dynamics of Earth's upper atmosphere and its response to solar activity and climate change. Auroras inspire wonder and appreciation for the beauty and mystery of the natural world, serving as a source of inspiration for many. Take a minute to admire these beautiful auroras recorded over the years. Seeing one makes you appreciate the beauty the world has to offer. It gives you a feeling of peace and serenity as you realize that there are forces operating beyond what humans can control. This is an exciting yet scary thought. The rare and remarkable event on Thursday highlighted the power and beauty of the sun. How about we try an emotional journey? A week later, I came back and created this iteration where you take a journey from the Earth out to the sun and back, with sonification audio kind of underlying this entire experience, while underscoring the challenges and opportunities of living in a solar system. The occurrence raises important questions about our preparedness for more powerful solar flares in the future, which could cause severe disruptions and damage to technology and infrastructure. Addressing such challenges requires consideration of how to mitigate risks and enhance the benefits of solar flares for society and civilization. It prompts exploration into what we can learn from studying the sun and its activity, and how that knowledge can improve our understanding and exploration of the solar system and beyond. Man's curiosity has taken him to space beyond Earth. It has allowed him to learn that there is more to our world than blue skies and cloudless nights. These discoveries have made it easier for man to come up with facts supporting various theories, giving a firm ground to science over belief. All these successes make it possible for current humans to predict various natural phenomena and prepare adequately for when disaster strikes. Gone are the days when we used locusts and birds to tell whether a flood was coming. Protons don't like to get close together. They have to come together with a huge amount of energy or velocity to get close enough to begin to fuse, and that's very, very rare today. So much is possible thanks to the advancements made in the technological and scientific worlds. As we applaud the team behind such interesting scientific facts, we don't forget that a bigger question lies ahead. If a larger solar flare is emitted by the sun, how prepared are we to ensure that our lives aren't interrupted in disastrous magnitudes? As the sun continues its life cycle as a middle-aged star, approximately 4.6 billion years old, ongoing scientific studies deepen our understanding of its complex processes, contributing to insights into astrophysics, space weather, and the broader cosmic context in which our solar system exists. In conclusion, as we continue to observe and learn from the sun, it becomes clear that it is not only our source of light and heat, but also our window to the universe and a guide to the future. Understanding and answering these questions will be crucial as we navigate the complexities of our solar system. Solar flares have been emitted, but the difference in this one is that it was least expected, and it is recorded as the big one yet in the current solar cycle. Scientists noticed that it had been unusually quiet, so maybe this was something to remind the Earth that the sun was still shining and all activities were still going on.